Hi guys, how's it going? So this video is going to talk to you basically about answering the question, how does Java store variables in memory? And we're going to see that there's some interesting differences between a primitive variable like an int or a boolean or a char and an object like we've been working with for most of this year. Okay, so let's just do something basic. So say you have a primitive variable. And again, this is an int, a double, a boolean, a char, something in lowercase generally. So if you set up some int x to be 3, and then you set up some y to copy over the value of x, and then you change that x to be 5. Watch what's going to happen now when we go ahead and print out the variables. So let's say x, and that is x, and then you'll say, put another space, and then we'll say plus y, and then plus, and then is y. Okay, so let's go ahead and run this and see what happens. And much to the surprise of hopefully none of you, you will see that this prints out that you have a value of 5 for your x, but the y is not changed. Because what this does is at this point in time, this says this sets y to be the value of x at this point. So this sets y to be 3. Now, when you change x to be 5, this just changes x to be 5. And what that means is it doesn't change y, it just changes x. Okay, but now let's do something different with an object. So what we're going to see is something totally different actually happens with an object. So suppose you have, okay, and just for your reference, I've made a person class here. Nothing special, right? It's just got a person with a name and change name. Nothing really happens there. Change name, get name, nothing new. So let's make a person p1 equals a new person. Okay, and let's set this up to be, I don't know, who do we want to make? Hammer and Hank Aaron just died today, very depressing. And now we're going to set another person p2 to equal p1. Okay, and now I'm going to change p1's name. So p1.change name to be Hammer and Hank. That was his nickname. So now we'll go ahead and print out the two people. So we'll print out P1 and P2 is, okay, and then we'll print out P2. I wrote a two strings, this should show up. And what you're going to see that I think is kind of interesting and worth our discussion is that something different happens here. Both of them got changed to be Hammer and Hank. Why does this happen? Why are they both the same? So to explain this, I want to draw you some pictures so we can kind of see what's happening here. All right, so if you have a primitive object, so we're going to be drawing pictures of what's happening inside your RAM, which I'm going to refer to as your memory. But this is where variables are saved when you run a program. So when you have a primitive object, like say int x equals 5. What that does is that just sets up a space in memory. It says I'm going to store an int variable x, and then it actually stores the value here. Now, when you now do this, when you say int y equals x, what that does is that copies over. So that copies the basically it copies the contents of x into y at this point in time. So it says, okay, at this point in time, what is the value inside x? It has a value of 5. So I'm going to set up an integer named y, or sorry, in my memory, I'm setting up an integer y that has a value of 5. Okay, it doesn't like point to x, it just has a value of 5. So in this case now, when I change, x to equal 20, it just goes in here and changes the value inside x to be 20. The y is totally separate. That's how primitive variables work. Now, objects work differently. So with objects, what happened is inside objects, Java just stores an address to a different location in memory. So when we set up a person P, Java sets up, okay, I'm going to set up a person, I'm going to call it P, and I'm just going to point to a different spot in memory. Let's say I'm just going to give it a random number 23, but that's just some random number. And then it goes down here. And that's where the actual data is stored. So inside here, this is where you have your person, it's got the name, Hank Aaron, and so forth. So now, at this point, when you set up another person, so let's say now you set up person Q to equal P. So what that does again is it copies, just like before, it copies the contents of Q into this new variable P. Okay, so we set up a new person. We call it Q. And again, it's saying, okay, what are the contents inside P? Well, inside P at this point in time, the contents are this address. It doesn't like point directly to Q. It just copies over that memory address 23. So what's happening there is the Q is also pointing to this location here in memory. So what's going on there is now when you call change name, so when you're calling this method, this p.changeName, so what Java is doing is it's saying, okay, where does P point in memory? P is pointing in memory to this spot 23. So this is like spot 23 in memory. So it goes down here and it calls the changeName method on that object. But because P and Q have the same contents, they both have that same memory address change, that's why it changes the name to be Hammer and Hank. So what's happening here is it's actually both of them are pointing to the same spot in memory. It doesn't like make a copy of it. It just copies over the contents, which are this address. So both of them point to this address in memory. And again, think of this as like an address at your house. Like you're pointing to this address in memory. So Q is also pointing to that same address for a house. So if you give that address to someone, if you change your house, like, I don't know, maybe you add another story to your house, or you just like blow up your sister's room, then person Q is also, when you give them your address, they're going to that same address. They're seeing the same changes to the house. It's still going to have that new floor, and it's not going to have your sister's room. So that's what's going on here. So what happened in our code is here, I changed y or x to be 5, but y I just copied over the value because it's a primitive. With objects, what happened is it copies over the memory address. So both P1 and P2 now point to the same location in memory. So what's happening here is both are pointing to the same spot, so changing one changes both. Whereas in this case, where we set y to equal x, because these are primitives, they don't have any address. So they just directly store the contents. So when you have a primitive, like an int or a boolean, it just stores the number. So changing one doesn't affect the number. They're not like pointing to the same spot like an object. Okay, so that's important, and that's what's going on there. So from this point in time, let's talk about other methods, because when you have another method, it does something similar. So let's say this is a famous type of question they love answering on the AP test. So say you have a changer method, and I'm going to put that in quotes here. So let's say now you have a method, and this method is going to be public static void. It's going to be a changer, and it doesn't matter if this returns anything or not. It's the same thing. This method is going to input a person A, and it's going to input an int B. Okay, and what I'm going to do is in this method, I'm going to change the variables A and B. So I'm going to change variable A. Let's say I'm going to change A.changeName. And I'm going to change his name to be Joe. Okay. And then B, I'm going to do B is equal to, I don't know, I'll just like add one to B. It doesn't matter. I could change another number. I could add one to it. So what we're going to do now is call this method from main. Okay, so to call this method from main, we're going to need to set up two variables here. So let's make a person P3 to be a new person, which would be Olivia Rodrigo, let's say. And then let's go ahead and set up just another int. So say your grade in this class, which would be 12. And now let's call this method. So we're going to call changer. We're going to send it P3. And then we're going to also send it grade. Okay. And then after that's done, let's go ahead and print out P3. And then we'll go ahead and print out grade. And I want you to make your predictions about what's going to happen in this method when I go ahead and call this. Okay, so go ahead and pause the video for a sec and then do that. Okay, so when we go ahead and actually run this code, we see it printed out the person was Joe, but the number was still 12. So let's talk about why this happened. So we sent it P3, and then it changed A's name to be Joe. Okay, but what's happening here is that A is pointing to the same place as P3. So it's having that same memory issue that we just saw before. B, when you do this, the same thing is happening, right? B is a different variable. So what happens here is when you call this method, when you call this method, it sends the current values of these variables. So it sends those contents. So it sends P3's memory address and then the value 12. So when you get down here, what happens is that this sets A to equal the memory address of P3. So it basically does A equals P3, just like you would expect. And then it sets B to be the value, to be equal the value of grade. So it sets B to equal 12. So what's happening here is because they have the same memory address, so changing it here changes it in the other method because they point to the same spot. Whereas this doesn't change grade at all because there are different variables. And again, ints are different than memory. So basically, when you're calling this, you should think of it as doing the same thing that you're doing here and the same thing that you're doing here. Like when you call this method changer right here, this sets A to equal P3, it sets B to equal grade. And I want to point out, this happens even though this is a void method. Returning doesn't affect this behavior. Whether you return a person or return an int or a void like this, the same thing is still going to happen because it's doing the same thing. Now, I want to point out something interesting here. What if you do this? I should probably put that in a statement. What if you do this? So what if now, so what if I comment out this a.changeName? But what if instead of that, what if now I set the person A to equal a new person? So, I don't know, let's do Mr. Gravel. Okay. Now, is that going to affect this P3 that I put up here? And the answer to that question, hopefully you can see, is no. It doesn't affect it at all. Because what's happening here is, when you do this, so you have like, your person P3, and that's pointing to the spot in memory, which is, that's where Olivia is stored. And now you have your other person down here. And originally, you basically set, this person, which was A, in this case, to equal P3. So initially, it set A to point to that same spot in memory, spot 12. But now, when you do this line of code here for a new person, A equals a new person, when you call the phrase new, what that does is new creates a new spot in memory. So A creates a new spot in memory. So it severs this link right here. And then now, sorry, you couldn't see that before. So it creates a new spot in memory. So when you call a new person, it says, okay, now I'm going to point to a new spot in memory. I don't know, spot like 13 if you want. And that's where we have a new person, and this is where Mr. Gravel is happening. Now, you could go ahead and change Gravel's name to be, Miss Smith or whatever, but that's not going to affect it because at this point in time, after you set A to be a new person, it's pointing to a new spot in memory. So that's what's going on there. Okay, so the answer here is now this points to a new spot in memory, and now it is a different place from that P3 in the other method. So same thing, I can go ahead and now, I could do a.changeName to be like Smith, and it's again not going to affect anything that's happening in my main method. It's still going to be Olivia Rodrigo because we point to a new student. Now, of course, if I printed out, A here, like it would say Miss Smith or whatever, but that's not going to affect it. Okay, cool. So that's what's going on. The only other thing I wanted to share with you in this video is that strings actually behave like objects. Or not like objects, sorry. They behave like primitives. So if you have some string, word1 equals a new string, yo, and then we set string w2 equal to w1, and then, you set w1 to equal w1 plus, and then I add on, I don't know, like yo, yo. Oops. Then in that case, what you'll see is the W1 and W2 are completely distinct. So W1 will be yo, 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 and then W2 is still going to be the original value, which is no. So the reason, by the way, oh, geez. The reason, by the way, that this happens, and there we can see the W1 is yo, yo, yo. Oh, obviously, hold on, I'm really stupid here. So if we print out W2, we'll see it's just yo. Yeah, okay. So now W1 has changed, and W2 has not. And the reason this happens is this is because when you use plus, it's not like a mutator method. It's not like a change name. All this does is the plus actually creates a new string. And same with substring or dot to uppercase. A string cannot be changed, so these all create new strings. So even though string is technically a variable, or sorry, an object, you treat it just like a primitive variable because everything is just creating a new string. It's pointing to a new spot in memory. So when you see something like this method, if something like this happens to the string, just pretend it's like an int or a boolean, and it'll work just like that. Okay, so thanks for watching this video. Please bring me some questions in class, and I'll see you guys soon. I know this is some crazy stuff.